2012 external, day 1. We're asked to solve, so we're looking for a value of x. A couple of ways we could do it. We could divide by 3, or most people would probably dive in and start expanding that, although you don't have to do it that way. Minus 27. Negative 12. Right, we're after to factorise. Coefficient of x squared is 1, so it's a lot easier. 7 times 4 is 28. Because we want negative 3x, the larger number needs to be the negative. And you can always do a check. We're going to get x squared plus 4x minus 7x minus 28, and there's your minus 3x. Now we're asked to solve, and notice it's exactly the same quadratic as above, so we can quickly write down its factors. And when you're asked to solve a quadratic equation, we need to rely on the principle that if a times b equals 0, then a is 0, or b is 0. It's really important that you've got your factors. Factor times factor equals 0, then we can be assured that one of the factors is 0. So to make one of the factors of 0, one of the factors be 0, we could try substituting x equals 7. Would give 0 times 7 plus 4 is 11. Either way we'll get 0. Or we could also substitute x equals negative 4 into this equation. The negative 4 plus 4 will give us 0 for that factor. Part 3, we're asked to simplify, and notice once again we've got the same quadratic on the top line. Now we can't just cancel where we like, because there's pluses and minuses on the top and bottom, and you can only cancel top and bottom when you have factors. Factor times factor. So the same quadratic. On the bottom I notice I have one lot of x plus 4. Now because I have factors multiplied, we can cancel out the common factor, leaving me with x minus 7. Now this next question is a bit tricky. It says show that x equals 12 is the only real solution to this here. You might be looking at this thinking, now that side there is exactly what we've got above, and I know it simplifies to x minus 7. Add 7 to both sides, you get x equals 12. There's a bit more to it than that. When you normally solve one of these equations, an equation like this, you should really take in consideration other solutions. So another way to have a go at it would be to multiply by the x plus 4. You're actually multiplying both sides by x plus 4. Multiplying that will give me 5x plus 20. Quadratic equation, will minus 5x from both sides. Will minus 20 from both sides. You can take your time and do it slower. Once again, this looks like it might factorise. 48 has lots of factors, of course. 6 times 8, 12 times 4. The 12 and 4 will give us the 8 there, which gives me x equals 12, or x equals negative 4. However, the problem with negative 4 using or substituting x equals negative 4 into the equation would give me negative 4 squared minus 3 times negative 4 minus 28 over negative 4 plus 4. And there is your issue, of course. Negative 4 plus 4 would give me 0 on the denominator, and 0 on a denominator is undefined. So the only real solution is x equals 12. Right, moving into some of the harder problems. The difference between the solutions to the equation is 10 to find the value of a. Right, Well, without looking too closely at it, we might minus the 30 from both sides. Minus 30 from both sides. Give me 0 on the right hand side, which is what I usually do for a quadratic. 6 minus 30 is minus 24. Now, 24 we could have 6 and 4, 12 and 2, 8 and 3, of course it has lots of factors. It's negative 24, so one of them would need to be negative and one of them positive. The difference between the two solutions is 10. So for example, we could have negative 12, then it would have to be negative 2. We could have negative 6 and positive 4. And that would have a difference of 10 between it. So let's just have a go at that. Let's try x minus 6 and x plus 4 and see what happens. Right, so solving that gives me solutions of 6 and negative 4, and the difference between that is definitely 10. If you think of your number line, negative 4 up to 0 across to 6, the difference between the two solutions there is a value of 10, which means if we expand this back, we'll get x squared plus 4x minus 6x minus 24. In the middle there, we're going to get x squared minus 2x minus 24 equals 0. So that means a would equal 2. Now just think about whether it should be negative 2, but it's already got the minus there. It's already got the minus, so a is 2. If a is 2, then the difference between the solutions would be 10. Quite a tricky question. Right, part C, a square room. In a hallway, I'd have carpet laid on the floor. The width of the hallway is 6 metres less than the length of the room. So we'll call the room x by x. Now it's square, yep, square room. Not quite sure where the hallway runs. We could have a hallway like this, couldn't we? Down to the room. The width of the hallway is 6 metres less than the length of the room, so that's x minus 6. The hallway is 5 metres longer than the length of the room, so that would be x plus 5. Just check that. Width of the hallway is 6 metres less than the length of the room. The hallway is 5 metres longer than the length of the room. Right. So area of the hallway is going to be x plus 5 times x minus 6. And the area of the room, of course, is x squared, and altogether I've got 123 metres squared of carpet. Expanding the quadratic, minus 6 plus 5. Now we're going to need to minus the 123. This is clearly going to be quadratic. Quadratic equations, we like to get 0 on one side. So if we minus the 123 at this stage, right, now factorising this is not going to be easy. We've got a 2 in the front, so we look for a common factor first, but unfortunately 2 doesn't go into the either of them. So we're going to have to factorise this with the 2 in the front. Right, so we're looking for factors of 153. I find a factor tree sometime helpful. Clearly 3 is going to go into this number. 3's into 15 go 5, 3's into 3 go 1. 5 plus 1 adds to 6. When the digits add to a multiple of 3, then 3 goes into it. So once again, 3's into 51, 3's into 5 go once, carry the 2, 3's into 21 go 7. So 3 is clearly a factor, 51 is a factor, we've got 17. And if you know about using factor trees, 3 times 3 is 9, 9 times 17 is going to equal 153. Quite a nasty excellence style question. So over here I'm going to use the gate method, 2 and a 1, 9 and a 17. Multiplying across, 2 times 9 is 18, 1 times 17 is 17, and in fact I could use them to get negative 1. We'd want negative 18 plus 17. So putting all that information into brackets, I want a 2x and a 1x. I want the 2 to be multiplied by 9, and in fact negative 9, so I get negative 18. And I want the 1 to be multiplied by the 17. And you can check it in a different colour. 17 times 9. And there's my minus 1x. So in fact it does work. I'm running out of room, so I'll just delete that. Right, so now we're solving. So clearly one solution would be x equals 9. Solving this one, we're looking for a value I can substitute into that bracket, and substitute in there for x, and get it equaling 0. So that's what I'm looking for. It's clearly going to be a negative number. If we solve it as a linear equation, minus the 17, divide both sides by 2. For excellence, you would need to make the effort to find that. Now clearly you can't have a negative length, so we'll call that unsuitable to have a negative length. So that means x equals 9. Now just check exactly what it is they want us to find. So of this equation to find the length of the room, well x was the length of the room. So the length of the room is 9 meters. And you could check that.